Okay, so apologies about the confusion yesterday morning. I just published the link, as I said on the message. I published the link just to the wrong channel, the link for the lecture. But these things happen, I guess. So what I want to do is just give you quickly a preview to this lab, which is this week's lab. You may have already started it, which is great if you have, but I'll just do a preview of it anyway. And I guess probably more importantly, to also chat about the assignment specification, which you may have hopefully have looked at, um, and you may have some questions on it. So in this lab, we're essentially taking what we covered in this lab and extending it. You might remember in this lab here, we created a CI pipeline on the GitLab platform or service. And I want to extend it to include CD, which is the deployment of our application. Now, for no particular reason, we're going to deploy it onto an EC2 instance on AWS. So if you haven't already done so, you'll need to create an account for yourself on AWS. It has to be your own personal account. You will have to use a credit card in the creation of it. We'll try to keep the expense as low as possible, and I'll give you one or two pointers as to how you might do that. Um, you probably will have to pick the paid tier rather than the free tier option, even though we still want to keep our cost to a minimum. So if you haven't created your own personal AWS account, you have to remember that in the creation process, that it's the paid tier and not the free tier option that you're going to be choosing. So in this lab here, what we are doing, we could have used the same application as last week, but for no particular reason at all, really. I've picked this just a slightly different application. It's still a JavaScript application. So this is the code here, and I give you this code as the as an archive that you download. Um, sorry, no. And just to show you what the application is, it's just a very simple uh, game, I guess you'd call it. If I run it locally, uh, can I just check that people can hear me and see my screen, just to be sure, to be sure? Does anybody want to confirm that? Can somebody confirm that they see my screen and hear me? Okay, I think there are some people online, so I'll assume that's a yes. And now just give me a second. Okay, yeah, if I run the application locally, which I can do like this, and you can as well. So it's npx rather than npm. What I'm doing here is I'm running a serve. Serve is just a simple web server. It's an NPM package that contains a web server within it. So I'm running that server and I'm pointing it at the current folder. That's what dot refers to, because you can see over here on the left there is an index.html in the base folder. And I'm just deciding to run the web server on port 3000. So if I hit return, that starts up my web server. And if I go to localhost 3000, this is the game, right? And you can play it away yourselves, but I think essentially the point is you have to kind of match up matching numbers. So we've got a 4 and a 4. So if I hit the left arrow, and now I've got a 2 and a 2 here as well, so I can hit the either left or right, and you keep on going. 4 and 4 if I hit the up arrow, and you keep on going until you get to 2048, supposedly. I wouldn't advise you to try and get all the way, but anyway. That's the game. So it's a simple web application, server-side rendering web application. So I'll just shut that down and I'll stop my server. So it's the usual story. We want to Dockerize it. Um, we want to Dockerize it. We want to, after we've Dockerized it, we want to just do a basic test to make sure that the Docker image is okay. And then we want to deploy it to an EC2 instance. Now, as I say in the lab, you have to create the EC2 instance first yourself, and I step you through how you do that. So if I go over to my AWS account, and I'm here in the EC2 service, and if I click on instances, I currently have, okay, I've got two EC2 instances, but we don't care about the first one. The second one is the one that um, I've configured for this lab, and you'll do the same. And it's currently running. And so I explained to you how to create your EC2 instance, and you probably remember from the module that you studied last year as well, the um, automated cloud services or whatever it was called. What you also need to do, and I explained it to you in the lab, is you need to create a key pair, which is a public-private key pair. You actually have to do that first, create your key pair. And as part of the key pair creation process, you download the private key onto your local machine. So I've done that, um, and I'll show you that file in a second. It's a .pem file. So I've created my key pair. Then I went away and created my EC2 instance, and I told it to use the key pair that I've just created which will allow me to SSH into the EC2 instance. So when you create your EC2 instance, that instance will get a public IP address, and I can find that IP address. Again, I guess you know all of this, but I can find that IP address if I go to the Networks tab down here, and it's showing me here what the public IP is. So having the public IP, I can then SSH to that instance. And so if I go to this tab here, and I'll just do a clear maybe first, kind of assuming now this is all familiar to you, even though it's maybe a while since you did it. So the SSH command is where? SSH. is like this. Okay, SSH minus L. This is just I'm telling it where the PEM file is. The PEM file is that contains the private key of my key pair. So it's a physical file on my file system. So it looks like it's two levels up from the current folder. And when you want to connect to SSH to an EC2 instance, you've got to specify what username you're connecting as, and it's always EC2 user at, and then the IP address of the EC2 instance. So if I hit return, I'm now connected to that EC2 instance. And what you will need to do is install the Docker daemon and the CLI in your EC2 instance. We do that manually. And I explain how you do that in the lab. So I've done it already. So if I go Docker, let's say PS to show me any running containers, it looks like there is a container running. So that's confirming to me anyway that even if there wasn't a container running, I am getting a response back from the Docker daemons. Because as you know, when we do Docker PS, Docker here is just the CLI, but this command is talking to the Docker daemon to ask it, tell me what containers, if any, you currently have running. And I got a response back, so that means the Docker daemon is, excuse me, is running. So that's fine. I have my EC2 instance set up and it has Docker installed on it. Now back to my source code and the whole role of GitLab. So here's my GitLab CI YAML file. And in fact, nearly most of the jobs in it are the same as the jobs that we had last week. Yeah, so here's the job that builds a Docker image and puts it up into my Docker Hub account. So we had that last week. Here's the job that pulls the image down again, runs it locally, and tries to curl to it. Okay, because the image is just a web application. So when we run a container with that image, the application is listening on port 80. Um, you would have to know that, but I'm just telling you. So, and I'm mapping port 80 to port 80 on the host, if you like. The host in this case is another Docker image, but that's just the way it is. I guess we know we're using Docker in Docker and all of that stuff that we talked about last week. So when I do a curl to this domain at port 80, I'm essentially trying to communicate with my with the Docker container that I've created up here. And I'm grepping for 2048 because I know that the home page of the game contains 2048 as a kind of a header. Yeah. So hopefully that runs and that proves to me that my Docker image is fine. And the last part then is to deploy my image, well, sorry, to create a container on my EC2 instance that is running this image. So essentially what I've got to do here is I've got to make an SSH connection to the EC2 instance and also run two Docker commands. One Docker command will be to pull down the image from Docker Hub, pull it down to my EC2 instance, and then start a container with that image. So, what am I doing? I'm using just a simple the base image for my job is just a simple uh, kind of baseline Linux image. That's what Alpine is. I'm installing OpenSSH on it. And essentially all I'm doing here is I am, let's try and step through it. I am kind of configuring uh, OpenSSH within this container because we know that these jobs run inside a container. So I'm configuring OpenSSH within this container and I am giving it the private key of that key pair that I created when I created my EC2 instance. So this variable here, SSH private key, that's an environment variable that I've created up in GitLab. Maybe if I, well, okay, I'll push on just for now and I'll show you this in a moment. So I'm essentially configuring OpenSSH and I'm adding my private key of that key pair to OpenSSH so that I will be able to make an SSH connection. So that's what's going on there. And then I try to SSH to my EC2 instance. So a lot of this is boilerplate, all of this stuff here. But you see here that SSH user is another environment variable that's set to EC2 user, and SSH host is an environment variable that is set to the IP address of my EC2 instance. So really what I'm doing there is essentially what I did from the command line a moment ago. You know, when I ran the SSH command from the command line down here, that's essentially what I'm doing up here. There's one or two extra command line options like this one here. Okay. And having made the connection, I then want to run these commands here within my EC2 instance. So I'm doing a Docker. Do I do a Docker pull? I'm doing a Docker. Well, I'm removing first any existing container that happens to be running that is running my image. App name is set to my image. Uh, and then I am starting a new container and I want that new container to run the image that I've built up earlier in this pipeline. I could have done a Docker pull and then a Docker run, but as you know, if you do Docker run and the image isn't available on the host in this case being the EC2 instance, then Docker will automatically pull down the image from Docker Hub and create the container all in one go. So that's what the Docker run is doing. Uh, and that's it really, right? So it's remove the current container and -F forces it to be removed and then run a new container with the new version of the image of my game that I've built up here. In GitLab itself, if I look at the environment variables, so let's see, we had kind of these ones last week, the Docker Hub token, that was so that we could do a push up to my Docker Hub account, just my Docker Hub username, that's okay. But SSH host and SSH private key, those two environment variables, you saw that I was using them in this job here. I'm referring to SSH private key here. and I'm referring to SSH host over here, SSH user, SSH user. I think I've declared actually up here. Uh, yeah, SSH user, and it's actually referring to SSH user for EC2, which I think I've defined in GitLab. There wasn't really a need for that, but uh, do I have that? Oh, there it is there. Okay. That this is just going to be set, this environment variable is just set to EC2-user, which you need to use when you're trying to SSH into an EC2 instance. It's kind of the default user name. SSH host, if we look at that environment variable, it's just set to an IP address. Where did this IP address come from? It came from here. And the other interesting environment variable is SSH private key. Sorry, that keeps coming over. SSH private key, and if we look at that, so it's got this. Where did that value come from, I wonder? Okay, and where that value came from is my PEM file, which is the private key of my key pair. So let me try and prove that to you. So there's the PEM file. And if I just going to make a copy of it and move it down into here. Don't do this now, because if you do this, you may accidentally, when you do a git commit to GitLab, it will actually include the PEM file, and clearly that's not a good idea. So the PEM file is there, which means I can now see it. Uh, I can see it here, hopefully. There it is there. And if I open it, yeah, that's actually, you just copy that entire content, and that is what you set this SSH private key environment variable to. That's the value that you see here on the bottom right. So where are we? You create your key pair on AWS. You create your EC2 instance on AWS. You install Docker on that EC2 instance manually. Then you switch over to GitLab. You create your GitLab project. You clone that project, which gets you to here. You copy all of the code, all of this code which I've given to you, copy that into uh, the GitLab repo that you've cloned. You add the GitLab CI YAML file, and you build that up um, and commit to GitLab. And as we know, every time we commit to GitLab, it will run the pipeline, uh, this pipeline for us. Um, I'll just pause for any questions if there are any. No. Um, Let me think. What's next? Yeah, in terms of if I go back to here, when you've got this is from a cost saving point of view now. When you've got an EC2 instance running, you are being charged uh, all the time, even if nothing is happening on that EC2 instance. So what I would recommend you do is when you're not using the EC2 instance, what you should do is select it, and then here just stop it from running. Put it into a stopped state. Don't terminate it, because if you terminate it, you'd have to create it all over again. So if I did click on stop there, then it would shut down my EC2 instance, and it would essentially put it into this stopped state that you can see this other EC2 instance is in. Then when you come back and you want to work on it again, you simply again select it again, and then put it into start it off again. Uh, Now, what you must remember though is that every time you restart an EC2 instance, it's going to get a new IP address. And so you're going to have to go into GitLab and set the SSH host environment variable to the new IP address that has been assigned. And everything else will be as before. The private key will be the same as before, etc., etc. So do remember that, because not just for this lab, but when you're working on the assignment, because you can use the same EC2 instance for the assignment, but you're going to be working on the assignment over a prolonged period of time. You do not want to really leave the EC2 instance running constantly over that period. Just stop it and start it multiple times. And just remember that it's a new IP address that's assigned every time you start it. So you'll have to go into your GitLab project and change the SSH host environment variable every time. Uh, this variable here. Any questions? I'd say not. Uh, oh yeah, there is one thing actually. So when I was preparing this, so if we look at it's actually a job from last week, that build and package job. Uh, Sorry, not that one. It's this one here, the test one. So we know what's happening here, right? I, I'm pulling down from Docker Hub the image that has just been built, and then I'm running a container with that image. And here I'm just checking, this line here is just for debugging purposes. I'm checking whether the container is running. I would look at the log in GitLab of this job. In other words, let's come out of here. If I go back to my pipelines, and if you want to examine a particular job, you go into the console for that. You know that from last week. So the Docker PS command, where is it? There's Docker PS. And so I can see, yeah, my container is actually running. It has only been running though for 1 second. Okay, that's fine. Uh, the next the next thing I do is I just check the logs of the actual image itself. That can be useful as a debugging aid as well, especially, if this job isn't actually running successfully, check the logs of the application itself, any console logs that it generates. And sorry, that's what I'm doing there. Yeah. And then I do curl. Now, what I found is if I take out this line here, and it goes straight from Docker PS to curl, this job actually fails because the curl responds to saying it's not getting a response back from the container. Yeah, like I can show you in GitLab. You see here when I ran the job, the second, sorry, when I ran the pipeline, the second stage failed. And if I try and find out, well, why did it fail? I know now there are two jobs here. I'll talk about the demo one in a second, but this this job failed. And so if I go into it and I try and find out, well, where did it fail? You see that the curl actually failed, even though when I do Docker PS, it's showing me that the container is running. It has been running for 1 second. I don't have the Docker logs command in this case, right? I disabled it. So it went straight from like here I'm creating the container. Here I'm just checking, is the container running? And then I try and send a request to the container and the request fails. Now the only uh, rational argument that I can make as to why it's failing is because even though the container is up and running, the container is running a web server within it. That web server hasn't fully booted up and it's not ready to receive responses. That's why it's failing here. Whereas when I go back to my pipeline and I just introduce this line here, sorry, yeah, I reintroduce this line here. And I don't think it actually matters what this line is doing. Really, what I want to do is delay the period before the curl command works in order to give my container, the web server within the container, time to boot up properly. And so when I introduced the Docker logs command, and as I say, it doesn't really matter what command is there. When I reintroduced it, now my pipeline worked, as in the curl command actually did connect to the web server and it got a response back from it. And all I'm doing here is checking to see does the response contain that kind of string within it anywhere. So these are the kind of quirks that you come across with these things. Okay, still no questions from me. That's all right. One other point that I want to highlight to you, if I go down through uh, my history of commits. So This pipeline, it ran, even though it failed, that's okay. This pipeline ran and it was successful. But when I did this commit here, there doesn't seem to be anything. It didn't even start the pipeline. Now, if you see that, the reason for that is there is an error in your YAML file. So it didn't even bother to start executing the pipeline. It checks the YAML first to make sure it's correct. And by correct, I simply mean that the indentation and alignment is correct. So I did mention to you that YAML is very sensitive to syntactic mistakes. Now, if you want to find out kind of where within the YAML was there an issue, if you click the failed here, you get an explanation. So it's actually complaining about a particular job within the pipeline. I think I had a typo in the job name. I called it TES rather than TEST. Sorry, in the job stage, I had set the stage to TES, and there was no stage called TES. It should be called TEST. So if you see that when you do a commit where it didn't even start to execute the pipeline, you now know where to go looking. Right, the assignment. Hopefully you've read it already. And it is to create a CI/CD pipeline for uh, another project. Now, the project is actually a React application. It's not that significant, but that's what it is. Um, Make sure you read these instructions as well. They're the most up-to-date ones. Let me do a refresh. Yeah, make sure you read the specification before you start this assignment. That's obvious, I guess, but you'd be surprised how many times I get people asking me questions, let's say a day or a day, 2 days before the submission time, and they've misinterpreted some part of the specification. So make sure if you do have any questions that you get them to me good and early. I have a real bugbear about Git commit histories. If there isn't a satisfactory Git commit history in your repository, then that raises kind of red flags for me. So do pay a lot of attention to committing. So, make small changes, commit, push. You don't have to push every time you do a Git commit, but you should certainly do commits very, very regularly and have clear commit messages so that I can see that there is a history to your work, that you certainly didn't produce code out of nowhere. It has to kind of evolve over time. Uh, and I would expect the commits to, what I'm saying down here is I would expect the commits to span out over a reasonable period of time. There's about 3 weeks that you have to work on this. Okay, you're not going to begin the assignment straight away, but I would still expect to see commits that date back to at least 2 weeks before the submission date. I don't want to see just commits happening 2 days or 3 days uh, before the deadline date. Only commits happening 2 or 3 days before the deadline date. There will obviously be commits close up to the deadline, but if the only commit history is for about 3 days prior to the deadline, then that doesn't really make any sense to me, and I would question that. And these two issues could affect your grade. Okay. So the objective is to build a CI/CD pipeline for a particular application. I give you the application. This is the deadline date. I give you the application. So download this archive. When you download it, what you will get is the following. Uh, as I said, it's a very simple React app, and I can show you the app here. Okay, it's a fairly unexciting to-do app. Uh, so whatever, do assignment, let's say, is the to-do. And it lists your tasks here, and you can delete it. Very, very basic. We don't really care about the application. That's not the focus of this module. And it's just a standalone React application. Okay, what you'll be submitting to me up to Moodle, you'll just submit a simple text file that contains the URL of your GitLab repo, and also you'll need to make a short YouTube video where you the uh, demonstrate the execution of your pipeline. I can give you more details on the video when it gets closer towards the deadline. Uh, there will be I'll provide you with a template for the README for the GitLab repo as well. And it's important that you fill out that template. Again, it won't take you more than, I don't know, an hour maximum to complete the README. I do want you to structure it in a certain way, and that helps me with the assessment of the assignment. So it's important that you follow the structure of that README template. And again, I'll give you that closer to the deadline. So the actual pipeline itself, I'm saying it should have all of these stages to it. Now, by build here, what I mean is because it's a React application, we have a sense of, I don't know if this has been covered in the web app dev module that you've been doing now. It may well have been, but when you cannot deploy a React app in the form that it is when you're doing your development work. You essentially have to convert your React source code into a static website. And it's that static website is what you deploy to wherever you want to deploy the app to. You cannot deploy the TypeScript kind of source code. So how do I build a static version of a React app? Again, you may already know this, but I'll just show you anyway. Just stop the server. You'll see up here on the top left, I have a dist folder. Well, if I actually just delete that, and if I run the command npm run build, build is, you can find what build means inside the package.json. Where is it? Scripts. There's build there. So it's just using the Vite tool to create a static version, as I say, of your React app. I'm not going to go into explaining how that works behind the scenes, but you can ask your web app dev lecturers about that. So if I hit return to my npm run build here, and if we look now again at the top left here, it has recreated the dist folder. And inside in that dist folder is essentially a static website version of my React app. Yeah, the actual JavaScript code is in this file here, I think. Yeah, there's actual JavaScript code equivalent of your React app. Now it's this form of the application that's what you deploy to wherever you want to deploy your React app to. Okay, and you might have noticed, when I ran the, let me just clear this down here again. Like when I was submitted this command here, again, I'm using the serve uh, web server, and I'm pointing it at the dist folder. I'm telling it that's where the website is. That's where the code for the website is. And okay, I'm just running it on port 3000. You can run it on whatever port you want to. So that's the same way that I ran um, that I demoed the 2048 game to you. It's just. I mean, I could use any web server that I want to, but this serve web server is just a nice, convenient one that um, you don't have to do much to actually install it. When you run this command for the first time, it will actually install the serve web server as an npm package, a global npm package. That's what's happening behind the scenes. Okay. However, what we're really interested in is Dockerizing this React app. And so here is a Docker file, and I've given you this Docker file. And what I'm doing inside the Docker file is essentially recreating what I would normally do out on the command line. So, I have to run npm install. I'm first of all creating a base image from my Docker image, and I'm using a version of Node version 20. Then I'm copying over the package.json into my working directory on the image, and then I'm running npm install because I need to add all the node modules to the image. And then I'm copying over everything being all of the source code. I have a Docker ignore here. If I look at the Docker ignore, that says don't copy over the contents of node modules into the image, and don't copy the dist folder into the image. Yeah. Because when we look at the Docker file, when we run npm install in the Docker file, that will install the node modules within the image. You could have done it with the copy, but it's more common to do it this way, and it's better practice to do it this way. So the copy dot will copy everything from what's here on the left, except the node modules on the left and the dist folder on the left. And then I run npm run build, and that's now going to create the dist folder within my image. And then I essentially start my server in the same way that I did down here. That's fine. Kind of went a little bit too far now. Back to here. The build command, the pipeline job that should satisfy this build stage will just be to run npm run build, npm install and npm run build within the pipeline. This is before we Dockerize it now. I'm not sure if I'm making that clear. Let me try that again. So this stage in the pipeline What it's meant to do is run npm install and npm run build within the pipeline, just to see that we can actually create a static version of the website. Because if there are errors in your source code, then the npm run build would actually throw an error, and that would stop the pipeline from running, and that would make sense. There's no point in going any further if there are some errors in your source code. The package stage in my pipeline, what I mean by package here is to Dockerize the application. So we know how to do that. Not only Dockerize it, but also push the Docker image up to your GitHub repo. The unit test stage, and I talk about each of these down here, but the unit test stage, the purpose of that stage is to run your Docker image in a container and send it a curl request, and maybe just check to see does the string to do appear in the response. Because when I ran it locally, did I shut down that? Let's see. Does to do appear anywhere? To do appears in the, I'm just checking now actually. Oh yeah, if you see here in the top right of the screen in the actual browser tab name itself, it has to do in the browser tab name. So that should come back. It's to do where the O's are in lowercase. If you see there in the top right of my browser tab title, oddly enough, to do doesn't appear in the body, but that's okay. You could take anything really. You could take created or task or grep for any one of those words. Yeah. So that's what the unit test is meant to do. When I talked about CI/CD in general, and I talked about the CD part, we said that we should deploy our application to an environment that is similar to the production environment. And we refer to that environment as the staging environment. Now, in our case, our staging environment is going to be the same EC2 instance as our production environment. And the way we'll distinguish staging from production is we will run the application on different ports. And I specify which ports you should use. So there'll be one port for the Docker container, which represents the staged version of the application, and it'll be a different port for the container that's running the production version of the application. And I talk about that down here. Let me see. So port 8080 is what I want you to use for the staged version of the to-do app that's running on your EC2 instance, whereas the production app is going to use port 80. Do I say it? Where do I say port 80? Port 80, there. Right, so they're the different stages that make up my pipeline. I've talked about the build stage, I've talked about the package stage, I've talked about the unit test stage, although there is a caveat on the unit test stage that I need to come back to. I say that, so we have this CD, which stands for continuous delivery, and it also stands for continuous deployment. And I've explained the difference between the two of them. And that's kind of what I'm talking about down here. So the way I want the pipeline to work is when you do a commit to the main branch of your GitLab repository, then the pipeline should deploy the application to the staging environment, and it should also automatically deploy it to the production environment. It's normal that you would only that you'd have more than one branch uh, in your repository, GitLab repository in our case, and the same would apply with GitHub. Now, what I've decided for this assignment is there are two branches that you will be committing to in your GitLab repository, the main branch and the second branch we'll call the develop branch. And when you commit to the develop branch, what I want your pipeline to do is run the build stage, run the package stage, run the unit test stage, run the staging stage, but do not deploy it to the production stage, or do not deploy it to the production environment unless there is a manual instruction to do so. Now, you will have to do a little bit of Googling as to how you might achieve that. Okay, so the triggering of the deployment to the production environment, that should require a manual kind of intervention, kind of a manual triggering of the last stage in the pipeline, the last stage being to deploy the application to the production environment. And again, that's something that we've not covered in the lab, and that's intentional. So typically oh yeah. So we have these two branches in our repository, the develop branch and the main branch. And typically the way it works is when you're developing a new feature for your application or you're fixing a bug in the application, you're doing that work on the develop branch and you're committing to the develop branch. When eventually you've completed that task, whether it be developing a new feature or fixing a bug, you merge the develop branch into the main branch, and then you commit the main branch. That's typically how these things work. But we know now that for our pipeline, whenever we can push both, we can push to both branches up in GitLab. So on one occasion, we might be doing a git push to the develop branch. On another occasion, we'll be doing a git push to the main branch. But the pipeline that's triggered will be slightly different depending on which branch we have pushed to. And that needs to be kind of coded in your YAML file. Again, I have not told you how to do that. You need to work that out yourselves by doing some Googling, I guess. The grading spectrum, you can get between 40 and 50% if you just get the build stage working, the package stage working, and the staging stage working. And you have the code for packaging already from the labs. You have the code for staging from today's lab. You know how to staging will mean deploying it to our EC2 instance and specifying which port it should be using to make it publicly available. And we decided it was going to be port 8080. If you want to get between 55 and 75, you need to implement the unit test stage. Now, you could take the code that we have for unit testing. Unit testing here, really what I mean by unit testing is essentially, I go back to what we were talking about earlier. This stage here, or this job, sorry, is essentially what I mean by unit testing. But the way I've written it here is not the best way of doing it. There is a much cleaner way of achieving what I want to achieve here. Now, if you simply use this approach, yeah, you will get some marks for sure. But if you try and come up with a better way of doing it, and by better I mean a slightly cleaner, less involved, less commands really. Let's talk about it. The script could be a lot shorter. This entire script could be a lot shorter if we thought about it a little bit. You'll still be using curl. That's not any different. But the way we actually get our container running our image, there's a much simpler way of doing it than the way I'm doing it here. And again, you'd have to try and think about that. But although I do give you one or two hints in the specification when we'll come back to it towards the end of the specification. So unit testing and the deployment and only the continuous deployment part of deployment. Like this deployment stage kind of has two parts to it. There's the the continuous delivery part side of it, and the other side is the continuous deployment. Okay, so whereas all of the other stages will only have one job associated with it, this one might have more than one job associated with it. But to get between 55 and 75, you need only get the continuous deployment part of the deployment stage working. For outstanding, okay, what's multi-stage? I should probably have said multi-stage packaging there now rather than building. I am giving you a Docker file. Let's go back to there. Let's look at the Docker file. Sorry, wrong project. There's the Docker file. But it's using this web server called Serve to kind of host my website. And Serve is not really a production standard web server. I guess the one that we'd be more familiar with is the Nginx web server. So what I'd like you to look at is to rewrite this Docker file so that we use the Nginx web server to host our website, the dist folder, to host that within the image rather than using this kind of low grade Serve web server. Now, in order to do that, you'd have to look up what I mean by a multi-stage build. Like, it's unfortunate, and I've mentioned this already, like the word build here has multiple meanings. When I'm using it here, it relates to the Docker file. When I used it up here, it relates to creating the static version of the website. But hopefully, I've within the spec and orally, I've explained uh, what build means in different contexts. Down here, anyway. Down here, when I talk about a multi-stage build, I'm talking about essentially rewrite the Docker file so that I can use something like Nginx rather than that Serve web server as the host for my static website. And also, you'd need to have the complete CD working. So you need to have both continuous integration, continuous delivery, and continuous deployment. Uh, that would need to be working within your pipeline. So you would be committing to a develop branch and pushing your developer branch to GitLab, and you'd be doing the same with the main branch, but the pipeline that actually executes would be slightly different, only at the latter end of the pipeline though. If you're going to go for real top marks, then okay, we are deploying our React app to EC2, but uh, there are other cloud services that we could use to deploy our React app to. One of them is a cloud service called Vercel. So if you follow that link, it'll tell you about Vercel. And so rather than deploying the production version of the React app to EC2, we'd like the pipeline to deploy it to a Vercel platform instead. So you'd have to read up on that, obviously. So we would have a job within our pipeline, which is now somehow uh, deploying the React app to a project that you've created on the Vercel service. Some notes. What's my time? Okay. And I guess I'm giving you these notes for a reason, but I think I've already kind of explained this one, right? The command sequence to build a static version of a React app is this sequence here. Okay, so you're going to have, so essentially that's really what the build job is doing. Sorry now for jumping around the place, but this build job here, what it's really doing is just simply that. Okay. And so if those two things work properly, then at least we know our static website is clean and it's ready for packaging into a Docker container. Okay, I'm telling you, if you do want to run it locally, that's how you run it. You can do that, but within the pipeline, all you'll be doing is this. Do not do this within the pipeline. The next one, there is a Docker image called Alpine curl, which is a simple baseline Linux image that just contains the curl utility installed on it automatically. You know, you will have seen in my cases, whenever I needed to use curl, I had to install it. Where are we? Sorry, go back to here. There, like I had to install it, but that's because I was using the default image, which is the Docker CLI Docker client, which doesn't have curl on it. But by the way, in passing, right, this the very beginning of this YAML file, it's just something slightly different from what we had last week. We have this default section within the YAML, and what you define there, as its name suggests, is any default kind of settings that you want for the rest of the pipeline. So for example, I'm saying the default image for a job is this image. Now you can override that within a job, but if a job does not have an explicit image tag, and does any of ours? So this one doesn't have an image. setting. Uh, this one doesn't either. And this one does. Okay, this one is using its own image. So it's going to override the default because I'm not doing any Docker commands here. So I didn't need the Docker CLI as my image for this job. Yeah, and also what you can define is the default services for your jobs. And in most of my jobs, I need the Docker service so that I have a Docker daemon available to me because most of my jobs are actually, you know, submitting Docker commands within the job script itself. Now, admittedly, this one down here isn't, I'm not doing any Docker commands here, so I don't really need that service, but excuse me, you can't, I couldn't put in a service uh, tag here and have nothing in it. It would still, the default would still override it. But if I did have a service tag, which kind of brings me on to this demo here, which I still have to talk to you about. I'll come back to that in a second. Oh yeah, I'm just telling you that anyway. Uh, it may be the case that you could use that image as a job image wherever you happen to be using the curl command. This note is about, yeah, this note here relates to, sorry, now let me read it again, the services option. Oh yeah, yeah, I'll come back to that in a second. And the final note is relates to, the fact that we're going to have two branches that you're going to be playing around with, um, a develop branch and a main branch. And so this is typically kind of the flow that you would be in the flow of usage of these two branches. You would check out the develop branch. So in other words, you set the develop branch as the branch that you're currently working on. You do whatever development work you're doing. Now, in our case, you're not going to be developing any code. You're going to be changing the YAML file and adding to it and fixing errors in it, etc., etc. But that still kind of constitutes kind of development work in this context. So strictly speaking, you should only be doing that when you're on the develop branch. And when you've got something when you've made the correction or the changes, whatever they are, you then do your usual git add and git commit, and then we do a git push up to GitLab, but we're pushing to the develop branch. And you would see that up in GitLab. It will automatically create the develop branch if it doesn't already exist there. So, if I go to my, and I look at, let's just go back to, let me see if I go back to here. You can see here I have, well, the master branch is historical, ignore that. I have a main branch and I have a develop branch. So I did do some commits to, or pushes, sorry, git pushes to the develop branch, and that would have triggered my pipeline and only executed certain jobs within that pipeline. Are you going to have to work out how do I control what jobs are executed depending on what branch has been committed to? And as well, if we go to the pipelines themselves, I thought you could filter by by branch. Let me see. Can I do that? Well, you can see here, right, which branch a particular pipeline execution relates to. In my case, most of them are main, but if we kept on looking down through them, we would find one or two that are develop. I thought you could filter these somehow. Branch name, yeah. So you could filter them if you want to. I don't think you really need to, but okay. So you're doing your development work on the develop branch, and you're committing to that branch, and you're pushing to that branch up in GitLab. Again, I'm saying development work, but it's really the pipeline is what you will be making changes to. Well, you'll be changing potentially the Docker file as well. That all constitutes development work. But also, so when we do a git push to origin develop, that's going to trigger our pipeline, as we know. Um, at some stage, and probably many stages, you will then want to merge the changes that you've made into the main branch. And so the way you do that, and I'm assuming you know this already, you first of all have to do a git checkout of the branch that you want to merge into, which is main in my case. Then you do the git merge, and you merge the branch that you're merging into main, develop in our case, and then you do a git push to main, and that's going to trigger the pipeline again. But because we're pushing to main, there'll be certain parts of the pipeline that will execute here that didn't execute up here, or vice versa. And then, you go back to your develop branch, do some more work, and you're back up to here again. So this is the kind of cycle that you should try and follow. I won't necessarily be checking to see that you followed it rigidly. I'll be just checking. I'll just be looking at your YAML file to see, uh, have you made the necessary entries in the YAML file to satisfy the specification. In other words, the distinction between continuous delivery and continuous deployment. The last thing I want to look at relates to this point here, and it's linked to the unit test stage. And I just need to tell you one or two things that I haven't covered up to now. Let's see. Right. So I've just got a demo job here, and it has nothing to do with the rest of my pipeline up here, right? I just want to highlight some points to you. So it's a job called demo. Okay, I just added it to the test stage. That's not in any way significant. So I've got the services set option here, right? And we know what services is. What services does behind the scenes is it causes GitLab to create other containers which we can then access within our main script. We can talk to those other containers within our main script. We know that already. So it looks like here, um, I want to run an Nginx container. Um, And if I want to refer to that Nginx, and Nginx is running a web server within it, as we know, if I want to try and send a request to that web server, the domain name of the web server is the same as the image name, which would be Nginx in this case. But you can give it a different name if you want to, which is what we call an alias. And I've just decided I'm going to give it the alias server. So that means down here in my main script, if I want to send requests to this container, I can just refer to it using the domain name server. Now, because this container is running a web server within it, I can actually send it a curl request. And you can see that the curl request is going to the domain name server. And it's port 80 because I know that Nginx is using port 80. Could be another port if the web server within this container was using a different port. Um, and you can have any number of services here that you want to. So I have a second service, which in this case is running the Docker in Docker, uh, Docker in Docker image. Now, even though that is my default image, because when we go back up to the top here, I said that my default image is Docker in Docker, but that default is overridden if you decide to include the services, sorry, if you decide to include the services option in a job, then the defaults are the default services are overridden. So I've just decided actually I want to include the Docker in Docker container as well. Now, uh, okay, I do have to install curl in this case because neither of these images contain curl, so that's okay. The point I want to make here is, so when I do Docker PS there, and the PS will show me the currently running containers, you would imagine that these two containers would show up as being containers that are running in my Docker daemon. Uh, but let's see, what do we get back? I want to look at the demo job. So there's the curl to the Nginx, and this is the response from the Nginx default kind of website. But when I did Docker PS here, it looks like there aren't any containers running. Okay, I am getting response back from the Docker daemon. So there is a Docker daemon running. And the Docker daemon that is running is the Docker daemon that I specified as a result of this here. Told it to run a Docker daemon. Now, you would expect that I should see this container running inside in that Docker daemon, but I'm not getting that. And the explanation behind that is this Docker daemon, sorry, this Docker daemon is only available to this script here. GitLab itself is running its own Docker daemon, and it puts that container into that Docker daemon, which I cannot access within here. So that's why when I ran Docker PS, this command, this client is talking to this Docker daemon, and it doesn't have any containers running within it because I didn't start any containers down here. I don't think knowing that fact is of any necessary use to you in the assignment, but the stuff here about giving an alias and running, like I can run any image here. It doesn't have to be a public image owned by Docker Hub. Uh, it could be your own images, any image at all that you have access to, any Docker image that you have access to, whether it be owned by you, owned by somebody else, doesn't have to be a kind of an official Docker image, which is what Nginx is. Um, right. That's all. That's the final point that I wanted to make to you or make you aware of. So again, I will pause for any questions. No? Okay, you can still ask me stuff over Slack if you have them. So I guess it's not until you start into the assignment that uh, questions may arise. So for the remaining time, E should work on the lab, I guess, which is the lab, this lab here. And I'll let you work away and any questions that you might have, I'll be here until around 12 o'clock or so. Okay, thanks for that. Bye for now.